From the classroom to the workplace, we work, we work. When we see the complete picture, we work in the classroom towards our future. We work.
My name is Kirby and I'm a product development engineer here at Lancet Barbados. My role here at the company involves process development and product testing to ensure that the product is safe and effective before it reaches the market. My studies in physics and electronics has helped me to understand the theory of how the human eye functions and the factors which affect the quality of vision. The lens is a structure of the eye that is primarily responsible for vision in conjunction with the cornea. Vision is achieved when the light rays are refracted through the cornea and lens, and the image is imposed on the retina. The lens is located behind the iris and is housed within the capsular bag. The focal length of a lens is a measure of how the lens causes light to converge or diverge. The point at which the light converges is called the focal point, and the distance between this point and the surface of the lens is called the focal length. The major characteristics of a lens that affect its focal length are thickness, radius of curvature, and refractive index. The surface quality of the lens and the alignment of its surfaces also affect its focal length. When light rays impact on one surface of the lens, they are refracted and travel through the lens at a refracted angle. When the rays reach the other surface of the lens, they are refracted again. The light rays, in essence, are traveling through the thickness of the lens. The smaller the center thickness, the quicker the light rays converge after being refracted. This results in a shorter focal length for lenses with a smaller center thickness, and a longer focal length for lenses with a larger center thickness. When light rays impact on the lens, the angle of the surface determines the angle at which the rays are refracted. Light rays that impact an angular surface will refract more sharply, that is, at a larger angle, than rays that impact a horizontal surface. Therefore, rays that are refracted more sharply will converge at a shorter focal length than rays that are refracted at a smaller angle. The larger the radius of curvature of a lens, the flatter and more horizontal the surface of the lens. Therefore, a lens with a larger radius of curvature will have a longer focal length, and a lens with a smaller radius of curvature will have a shorter focal length. Light rays refract when they impact the surface of the lens. Therefore, the quality of the surface affects the uniformity at which the rays refract. A lens with an uneven surface or poor surface quality will result in the light rays converging at various points rather than at a single focal point. This results in a focal length that is not clearly defined. Light rays refract when they impact on both surfaces of the lens. Therefore, the alignment of these surfaces affects how the light rays converge. When both surfaces of the lens are perfectly aligned, this will result in the light rays converging at a single focal point. However, when the two surfaces are not aligned, this results in the light rays converging at more than one point, and this in turn creates more than one focal length. The refractive index of a material is a number that describes how any radiation, including light, travels through the material. A lens made from a material with a lower refractive index has a shorter focal length, and a lens made from a material with a higher refractive index has a longer focal length. As a manufacturer of medical devices, we at Lancet are required to conform to international standards. These standards include having a quality management system which outlines every aspect of the manufacturing process, from the design phase straight through to commercialization of the product, to ensure that we deliver products of the highest quality to our customers.
From the classroom to the workplace, we work, we work. When we see the complete picture, we work in the classroom.